Hello, welcome to the Center for Aerospace Education here at Windward Community College in Kaneohe. I am Dineene O'Connor. I'm the manager of the Hokulani Imaginarium, and I'm in the Aerospace Exploration Lab. Isn't this a wonderful place? It's filled with low-tech science toys that allow us to understand and observe forces and science, that phenomenon behind aviation, aeronautics, astronautics, atmospherics, and astronomy. When we can do so many experiments and with the toys and the science toys in this room, and I'm going to show you how we do those experiments right now. Let's make some observations about the forces in flight. There are 4 forces in flight. Thrust, which gives us lift, then weight, which is gravity, holds us in place, and drag, that allows us to move forward. Let's demonstrate those with a few gadgets that we have here. Let's just think of my arm as the wing of an airplane. So, what would this be if it were on the wing of an airplane? The jet engine. You're right. Okay, let's pretend. You know, there's a lot of pretend in science. Let's pretend that this ping pong ball is our plane. We're going to turn on our jet engine. Our plane, the engine gives thrust, which gives lift for our plane. But why doesn't it go to the ceiling? Because weight, the force of gravity pulling things towards Earth, keeps it in balance. Now, drag is allowing our plane to move forward. Drag is a little bit harder to demonstrate with this, but just consider, have you ever flown a kite and forgot to put the tail on it? Yes, the kite, you might get it up in the air and it will bobble back and forth. And pretty soon the bobbles will become extreme. And then pretty soon it goes into a spin. But when you put the tail on it, it bobbles. Yes, it still bobbles, but it's not so extreme because the tail is holding it down and stabilizing it so it can continue to move. That's what drag is doing for the 4 forces of flight. Okay, now, what if we wanted to turn our plane into a rocket ship? What force would we have to overcome? Just consider, a moment ago, our plane was staying pretty balanced and could move. But now, we have to overcome a powerful force that keeps everything on Earth. That force, you're right, it's gravity. So what would we do if we wanted to turn our plane into a rocket ship? And we use this little gib, okay, a tube. Where should we put it? Under our plane? Because we want it to go higher? Do you want to try that? Oh, what we're doing is designing an experiment. How many say under? I think I hear some people saying we should put it under. Let's try that. Okay, and our prediction is that our plane will become a rocket ship and go higher. Now, in a science experiment, your prediction is your hypothesis. Let's see if this works. Okay, we're going to put it under. That did not work. our plane did not go higher and become a rocket ship. Okay, does that mean that was a bad experiment? No, because we learned something. Even when our experiments don't result in confirming our prediction or our hypothesis, they still teach us valuable things. So let's do this again. We tried it under before. Let's try it on top now. Let's try another one. I think we had much more success that time. So what was happening there is that the thrust from our engine was forcing so much lift through this tube that we overcame the gravity that was holding the ping pong ball in place. And that's what you have to do. When you're a rocket ship, you have to get beyond Earth's powerful gravity. So, let's consider one more experiment. What do you think? Do you think we could get 2 ping pong balls flying at the same time? Where would we put this? Could we put it under here and see if the thrust will lift both? Should we put it over the top? You know what I'm going to do? I'm going to let you do that experiment. But remember our observation, when we wanted our ping pong ball to become a rocket ship, when we put it underneath, it wasn't as successful as when we put it on top. So think about that as you do the experiment to see if you can get 2 ping pong balls balanced and floating in space. That's our experiments. We've done 3 experiments in just a couple of minutes. So please, thank you so much for dropping by the Aerospace Exploration Lab and come back. Aloha.